Hi everyone. Are you able to see my screen?
Yes, we see the screen.
Okay, yes. Perfect. Diego, do you want to take?
Yes. I'm just gonna let you know when we need the next slide. Okay, so hello everybody. We are Diego, that's me, Lakshmi and Christine, and been preparing this lecture for a couple of weeks. It's going to be 3 hours, so don't get scared. There are going to be some breaks in between. So I would say let's jump right into it. Okay, we would like to show you what is the challenge that we face with cities right now, the rapid growth that's taking place, and what can we do with cities in the climate crisis that we are experiencing right now. And as I mentioned, there's going to be room for breaks and also for discussion. There are other topics like mobility, urban life quality, and I am also going to show you one example of a project we did some time ago in West Africa. Okay, so well, here we see what we can call a mega city. It is the city of Tokyo, and it has, depending on how you count it, between 30 to 40 million people together. So this city is not an exception anymore. Some years ago, there were 3 or 4 cities. Now this phenomenon is increasing. So cities that are big are turning into mega cities, and small towns are turning into cities. So what's actually happened here, see in the next slide, cities produce 70% of the GDP, gross domestic product. They also consume 60% of the energy. But with these two, let's say, positive factors, there are also two negative outcomes. 70% of the greenhouse emissions takes place in city. So it's mostly the energy we use for our houses and workspaces, but also for transportation. And also they produce 70% of the waste. So we see this clock that is ticking. There is this message everywhere. We need to change the way we live, make it more sustainable, and then the question arises: okay, what is sustainable, and what is a sustainable way of living? Well, we haven't always lived in cities. We're all familiar with pictures like this and stories of the early human beings being just hunter-gatherers. And there are very good estimations of the amount of time that they actually needed to work, and it's between 3 to 4 hours a day. So most of the time they just enjoy themselves in the outdoors, and they have time to, of course, do like paintings, like what you see on that picture. But then we learn in school, or at least that's how we learned at the time, that a revolution took place, the agricultural revolution. So people started to grow crops to have food, and some historians say, well, that was actually the worst mistake of mankind, because they have a life where they didn't work that much, and then in the end you became a slave of the crops that you needed to grow. So there are some historians that write that the human being, this ape, had been living a fairly comfortable life, hunting and gathering until about 10,000 years ago, but then began to invest more and more effort in cultivating wheat. If wheat didn't like stones, humans had to clear them from the fields. If wheat didn't want to share its space with other plants, people were obliged to labor under the hot sun, weeding them out. If wheat craved water, people had to lug it from other place to another, and so on. So from the perspective of some historians, actually, it was a plant like wheat that became very successful, and it started in this region, and then now you have it all over the place. But in the recent years, there has been a very interesting research showing that this is probably not the case. And what we saw here was not actually a revolution. It took place during 3,000 to 4,000 years. In crops, domestication is what happens when plants under cultivation use features that allow them to reproduce in the wild. Among the most important is the facility to disperse seeds without human assistance. In wheat, seeds growing on a stalk are contained by tiny aerodynamic capsules known as spicklets. As wild wheat ripens, the connection between spiklet and stem shatters. The spiklets free themselves and fall to the ground. Then the spiky end penetrates the soil deep enough for at least some seed to survive and grow. Others end up project upwards, equipped with a bristle-like awns to deter birds. In domestic varieties, these aids to survival are lost. A genetic mutation takes place, switching off the mechanism for spontaneous seed dispersal, turning wheat from a hardy survivor into a hopeless dependent. So these theories tell us that it was very likely that humans got in contact with plants to produce baskets and homes, like what you see on the right. That's a reproduction of a Neolithic hut. So humans started to adapt their environments to create comfort. Let's say what you see here is a courtyard where when the sun is shining a lot, to prevent it from overheat, you can just use a canopy to cover it. Or if you live in a place where where even the wind is hot and you also need protection, you can have a tent and add some extensions to create wind protection. And you also had this strategy of vertical migration. So you have a building that where you have different comfort situations depending on where you are. So if you're closer to the ground and lower, if the temperatures drop, you can go to the upper part where there's more sun. So we see this feature of adaptation everywhere where humans are, and of course we see them today in cities. Then what were actual revolutions were 3 industrial revolutions that we have seen. And an industrial revolution is characterized by ways of transportation, communication, and energy that it's used. I'm gonna repeat it again: transportation, communication, and energy. So if we look at the first industrial revolution, we see that the energy that they used was steam. The steam engine was a invention that people say it didn't take place earlier because they didn't know how iron worked or how to turn iron into steel. So in order to make a machine that produces steam, the pressure that is inside has to be made out of a very, very strong material. So iron couldn't make the work, and then steel did it. And you see here that the means of transportation changed. So roughly when at 1850, in this example of England, you see that when you see the start of the second industrial revolution, you see that the means of transportation change. So so you have railways all over the place, and you see that these railways make a connection between nodes where that are located next to water, let's say the ports of London, Manchester, Liverpool, that also give you a connection to the rest of the continent. And finally, we see a third industrial revolution that started in, let's say, the late 60s, where we see a digitalization in most of the areas of the planet. One example of that is especially what we are doing right now. We are in different parts of the world and can have a conversation. And the ways to move changed now with cars that run mostly on oil. We have a big change in the way that we move and also the emissions that go into the planet. And this is what we see in the next slide. You see this population growth, where you see the different regions of the world and how between the middle of the 20th century and the beginning of this century, different regions have different paces of growth. Focus on Africa and Asia just to see how this expanded. And the next slide shows us how I think we should see the emissions by now, actually. Exactly. Have been increasing during this period between the middle of the 19th century and today. And we also see interesting that people were warning since the, let's say, late 19th century that this is happening. And we also see different agreements between countries taking place since the 70s and even last year. But in the end, the emissions keep increasing. And here we see also that not only that, we also see, let's say, the little chart in the upper left shows us the increase in population, but also the increase in carbon emissions. And this trend is in things that you could classify as positive, let's say people having access to health, to urban environments, but also the depletion of forests, for example, or the acidification of oceans have been increasing at the same rate. And now we see a forecast for the next century, where you see that the greatest growth is going to take place in Africa, and is going to have a very dense population, even denser than what we see in Asia today. Here's another chart just for you to say, like, this is the expected growth that is going to take place in different countries. So here we see the square meters that are built already on the left, and the ones on the right, the ones that are expected to be increasing. Of course, China and India are the first ones, and of course countries, and then Africa as a continent. But exactly the regions where this growth is going to take place are I think in the next slide. Well, this is the phenomena I mentioned at the beginning. Here we see that small cities are going to turn into big cities, and mega cities are going to be increasing. So it is expected to have 41 mega cities by the year 2030. And well, this chart shows us that as people get together to work, they also become more efficient. So this is a research done by the World Bank, where they show each line in, let's say, the lower right, how the agglomeration of people in different countries during a specific time increase the economic output, and then it evens out. So this graph goes up and then becomes steady horizontally. And what you see on the right are the regions where people live in former settlements. And the first chart in the first map, the second one shows you people that don't have a lot of connectivity, and the third one shows you where the largest growth in population is going to take place. And here you see it's going to take place more or less the central and western parts of Africa.
Okay. So next, we are going to look at the chapter of what is sustainable cities and what does it mean to have livable cities when we have such mega cities coming up. I think we've all seen those pictures where it's like a concrete jungle. Do we really want to move towards a future like this, right? So we look at the multi-facets of urban planning, because it's quite a complicated topic, right? Because a city involves everything, right? So if we look at the sustainability aspects of urban planning, when cities are born or when they grow, we affect environment and biodiversity. Forests can be depleted. We need resources. So if we don't do this sustainably, then we cause deforestation. We can cause loss of animal habitat. We can destroy the water quality of our rivers. We've seen this happening around us everywhere. What else can cities affect? We obviously affect the resources. The resource consumption and CO2 emissions is highly affected by how our cities are planned, and we can control how much energy consumption that we have, and in turn the fossil fuel dependency, water demand as well. As you know, in different cities, the source of water is different, right? Some places are in the desert, some places are on islands. So some places have really trouble with getting water, and pollution, right? Our cities affect how air pollution happens with the transport. We create noise, we destroy the water and also the soil by removing forests and the natural plants, and we also cover up. We build roads. We basically make the ground impermeable, and thus we affect the soil quality, and we also affect what can grow in the future. We also dump waste in landfills. And how does this, and what about quality of life in our cities? Our health and well-being is affected by traffic safety. How it also affects crime rate. You know, if streets are lit well, then the crime rate is low. If air quality is better, our health is better. If the cities have green spaces, we have better health and well-being. People tend to be more outside. People tend to exercise. People tend to walk outside to spaces if they feel like it's walkable. And what happens with the quality of public spaces? So if there's a nice square, then people tend to be outside. People tend to want to spend time there and talk to their neighbors or to their friends, have public interactions. This improves also their mental health. When you have good outdoor comfort, then this also increases sociability. When we have nice outdoor spaces, it also affects economy. When you have access to a lot of people, when in public spaces there are a lot of people, and then businesses are created. Cafes are born, and then the city becomes attractive to outsiders, and more business gets attracted to the city. This is already happening, but we have to also look at. But some aspects might not be looked at, like the health and well-being. how can we create synergy between sustainability and while maintaining a good quality of life, right? When we protect the environment and we build more sustainably, we can reduce the resources that we consume and hence reduce our carbon emissions. This in turn will reduce pollution. We have less air pollution. This affects, obviously, if we have better air quality, that means our health is better, well-being is better. When we have less noise, when we have nice outdoor spaces, sociability increases, hence also economy grows. So it's all interconnected. And this is what we need to fight for and show that, growing economy is not in isolation of sustainability. They all go hand in hand. Now I hand over to Christina.
Yes, thank you, Lakshmi. Hello to everyone. Yeah, now we talk, when you go one sec quickly, about Lakshmi, can you go back one?
Yeah.
Yes, we heard about the multi-facets from Lakshmi and all these patterns and different dimensions we have to consider when we think about the city, really complex. So now we want to narrow it down a bit on more concrete points. The first of it is density as a key for climate neutrality. And we will see now why and how. I can go further. Because the key question is what we've seen, Diego showed, like we have an increasing population and we're already so many people, 8 billion right now, we are tending to be 10 billion soon. So how can we house all these people? It's a really basic question. And now we have one Earth, not that big for all these people. So we really have to think, okay, how do we house them? And here we see two different ways of housing. On the left in Atlanta, on the right in Barcelona, two different typologies. And you can see already on the left, it's really not a dense area. In one of these houses, probably living as many people as in really one apartment, you can see on the many in the right. So density is a big issue and it can be, must be the way of housing all the people. It's also when we look into the numbers on the next slide and the general footprint of the cities. On the left, you can see the footprint of Atlanta, and on the right, you can see the footprint of Barcelona. It's the same scale, so you can see a really big difference. And on the left down, you can see the population of both cities is more or less the same, 5 million people. So really a huge difference. And you can see the urban area is from 7,000 to 600. It's a factor of 10 smaller with the same amount of people. And when you look about the carbon emissions, here you can see the transport related ones, 7 tons of CO2 per year. And on the right, a little bit more than 1 ton. You can see that's really a major feature, is to reduce carbon emissions to build more dense. On the next slide, you can see the footprints again, and also the metro lines. And you can see how it's related. The CO2 emissions are, of course, much lower because you have, through the metro lines, a really good public transport. Lakshmi will talk about this later more, so I will keep it to her to point out the benefits of public transport. But here you can see the spatial dimension of both cities. And on the left in Atlanta, of course, it's much more car dependent. And on the right in Barcelona, we have really different modes of transportation. The next. Another thing you can see here is the population density in built up areas. Here you see a lot of different cities. The red ones, here right, red one in Barcelona and left Atlanta again. You can see in Barcelona, it's like on the very left, like where's the one, there's kind of the city center and the density. And the more right you go in the chart, the more outside the city you go. And you can see like in the city center, it's really dense and then it's going lower and lower and lower. And what you can see in Atlanta is like a really, really flat curve. It's like really not dense at all. And then you see some other cities and some other city structures or like density shares. And this study led to some strategies or some basic fabric structures, how you can define a city. When we switch to the next one. here, the common urban spatial structures, which are based on the density where people are living. You can see the more red the parts are, the more dense. That's a theoretical city, not a real one, you can see here. In the top left, yeah, where Lakshmi is pointing out, here you can see a really classic, typical city with a really big center, like we saw it in Barcelona, and then it's like going lower and lower with the density. Below that, you see the small urban area, like how a typical smaller urban area looks like. You have many small centers which are interconnected, so you have the mobility in between, while in the big city, always people are going in the morning all into the city center, and in the evening they go out again. So what's the perfect scenario, which is like a planning theory? There's no real city built like that, but to have the benefits of the centers as a city, but also not like overwhelming one point with all the people coming in and out, having all this traffic issues and density issues coming along with that. This is kind of the theoretical best option of having like many different centers which are really nicely connected with each other. In reality, it often looks like the bottom one. It is like the megacity model we see here. You can say like you have a combination of kind of the villages and the city center. So that's the reality. But it actually is like going into the direction of having dense cities which are good interconnected. So we see that density is a really crucial point, and how we design it, how we make mobility within the city, this is like a big topic. And when we think about a really dense city, there's also a question, okay, when it's super dense, like the first picture we saw, how can we create livability in it, which is key, of course, for having cities for people and not just city for housing. Here you can see already like one approach, like when you think about having a more dense building structure, you have more space for public space and other benefits. We'll jump in that later. So when we think about urban sustainability and livable places, we have to think about resilient urban infrastructures. We have dense cities, and they have to have a good infrastructure network to work in all different levels, in all the different aspects Lakshmi said before. So there are really a lot of dimensions of infrastructure. So you can think about supply and disposal, where goods are coming from, where's the waste going through, we have the mobility infrastructure. Of course, a really big issue. We have also digital infrastructure. How do we have the connection to Zoom right now that you can listen to us? And then we have the energy infrastructure, really crucial point, social infrastructure, and blue and green infrastructure. And since Lakshmi will talk about mobility in a bit, and we decided to leave out the supply and disposal and digital for other topics, which would be too much to talk about now. I will talk now about these three when you go to next. The energy, social, and blue-green infrastructure. And let's get started with the energy infrastructure. You heard already a lot from our colleagues about energy and buildings, so we don't have to talk about that too much. But here again, the global emissions share, you can see by economic sector, you can see the big yellow part, which is electricity and heat production. Just the energy production makes already most of the CO2 emissions. And also in the other parts, there's at the end of the day, most of it is energy supply. So energy is everything. Can you go next? So to become carbon neutral, there's no other way than to make the energy shift from fossil fuels to climate-friendly energy sources. And you heard already what all this can all be, from wind energy, solar power, electric vehicles, all this kind of different energy sources we have to switch to, we have to think about them when we develop cities. We saw it on a building scale, but really important to say is that energy is always a network. Of course, it can work within one building, if you have a PV panel and work for itself. But at the end of the day, it's more efficient and makes more sense to think it as a big network. You have PV panels outside the city. You have maybe wind power plants outside the city. You can have solar panels on one roof and maybe feed the electricity to the neighbor. Like here you can see it's just more like an idea of how you can interconnect all this energy. Like also cooling and warming is most efficient when you think it together. Waste disposal and making energy out of the waste, you can also only do a bit more centralized, which doesn't have to be really big centers, but within a district you can be and create really, really efficient and working energy infrastructures. So you always have to consider your building within the context of the other buildings. Another feature is like renewable energy is usually local energy. You have a PV panel on your building and you have your energy for yourself. You can maybe use energy out of the river for cooling and so on. So when you're not having fossil fuels, which are usually coming from really big power plants, which are centralized and organized by our government or so, renewable energy is usually local, so run by locals. And by that, it's also an independent energy. You're not relying to the big energy grid. If you have your PV panel, and that's what you can see here, that's an energy concept we did for a district. You can see the entire district is producing so much energy through photovoltaic that at the end, and by geothermal energy from the ground, that the heating and the electricity need is basically working in itself, supplying the district with electricity for the building, but also for all technical devices, for cooling, for heating, and also for a bit for electric mobility. On the left bottom, you can see the grid, the public grid, as kind of a buffer or like a battery kind of in a sense. But when you think instead of a battery, you would have a self-sustaining independent district. Exactly. Then the next point about big energy concepts is always really individual. Here you see from the International Energy Agency, the floating diagram of where does energy come from and where does it go to. And you can see like it's really distributed. We have oil, we have coal, we have some renewables, and it's a global average. When we jump to the next slide, we can see it for Zimbabwe, and you see a huge shift. You can see a lot of bio-waste production. So we have a total different ground situation to think about the energy concepts than when you look on a global scale. So what I want to say here is you cannot just take a concept you develop for another part in the world or for the entire world and just apply it locally. An example in Zimbabwe, there's always an individual strategy. You have to look at what is there and what you can make out of it and how you can make a change from fossil fuels to renewables and where's the biggest impact you can do. And here that's really interesting differences, I thought. So let's go to the next one, blue-green infrastructure. What is it and why do we need it? So in all cities globally, or most of the city globally, in Germany we have it more and more, but of course in African cities it's already much more there. We have hotter years, it's getting really warm, and in city centers, which is basically usually it's like a lot of concrete in the cities, the buildings, all public spaces are made with streets, so there are few green areas and a lot of building structures. So what we see is that like in the city center, we have the urban heat island effect. So it's getting really hot just because of the environment in the city. When you go out of the city, it's usually more land, agriculture. You have less high rises, which are stopping winds to cool down the city. So you have the effect that in cities, you have always really hot outdoor situations. And with that, also really uncomfortable time most of the year inside and outside, or you have to cool by electricity, which increase our electricity demand. We have to go down. The other problem is in many cities in the world. Next slide. The problem of flooding. also usually cities are really vulnerable if it's really dry for a really long time, and then it's suddenly raining a lot, and you have all like concrete streets and cities. The water cannot drain, so you have floodings in the cities. And this is more and more happening, causing a lot of damage, which will be increasing in the next decades more and more. So how do we deal with that? The concept is called Sponge City. It's a really popular name. And it's actually the idea of that the city works as a sponge. And here you can see an example. What does that mean? You have, instead of just streets and concrete, you open up the city, you have green spaces like here, which are at daytime or with nice weather, also nice outdoor areas. But when there comes the rain, it can be flooded and store the water without flooding the entire city, but really just this area which was planned for. At the same time, you can also save the water coming when it's raining, and by that using it to water the plants for the really dry seasons. This is a concept which is applied more and more in many cities, and every tree can actually help to improve the water and heat situation in the city. Yes, and what's always important to say, so I added this slide here, that you don't only have to see the infrastructure of blue-green or energy as independent, you can also integrate them in a building. An example here, you can see how green facades, just green stuff on the balcony, green roofs can be combined with PV panels on the roof to create electricity. There can be also PV and greening on the facade and on the roof, not only in the public spaces we saw it before.
If I just can add something, now it's also very common to have a green roof and then also a PV panel on top with a little bit of gap. So you can really combine both of it.
Exactly, which you cannot see here, but it's how Lakshmi is saying. And another thing is the blue-green infrastructure, as you can see, is really creating livable public spaces. And this is a project, Transsolar in Paris, where you can see how the water is also making good microclimate, and the trees are making shadows to make it really comfortable there. So this leads us to the third point, the social infrastructure. It's something really qualitative, but really, really essential. When we talk about social infrastructure, we talk about that, like you see hospitals, schools, community places, public space, all the green around it. This is really essential to when we think about a city for people. So social infrastructure is really crucial and important, and it's not only always about big infrastructure planning as you see it, and it's always the question of how you can build it and where you can build it, because usually there's not a lot of money for it. So I brought this project. I didn't do it with Transsolar, but with my nonprofit organization. And it's in the center of Stuttgart, and we have this situation in Stuttgart as well. There are really few public spaces, but we have a lot of cars and we have a lot of parking lots like here. And the question, can a parking lot be a social infrastructure? We kind of challenged, and in the next slide you can see how we tried to make one out of it. We convinced the city to remove the cars as a parking lot and just open it to the people. And here you can see what happens, like how everyone comes and just uses the place, like how in a way individual thing which is good for the city, for themselves, what they're into it, like there are discussions around, there's just a coffee for everyone. People came and brought trees into the space. We didn't do a lot of it, most of it came from everyone. So you can just rethink a parking lot as an infrastructure without any building, just with people. On the next slide, I have another picture, how we just eat together, and in the background, you can see a choir. And I guess like when you think about your environment, your city, there are many of these places which are not made to be for people, but you just use them for people. And that's something to enhance and make space for it and make it comfortable by having trees or a roof like here. Another thing, how you can integrate energy and public infrastructure, social infrastructure, something like that. You can create nice outdoor spaces by PV shading, which is also producing electricity. Or on the next slide is a project example, which is a bigger infrastructure building project. This is a big sports area in Rotterdam where it's a public space. You can do sports, as you can see, also have real games. There is even like a podium. But at the same time, it can be used if there's a hard rain. On next slide, you can see it. It fills up and works as a flooding storage infrastructure, and gives at the end, like, the water will be stored, and as I showed earlier, is used to water the plants and the city green with it. So, and not flooding just this area. So before we go into the break, we plan to have a break now. I would ask you, and you can maybe think and discuss that, how can this 3 dimensions, okay, but we're back, Lakshmi. How can the 3 dimensions I showed to you can be combined in your city? What can be like measures to do that? I showed some, but I guess in your places it's much different than what I showed to you. So maybe that could be a discussion you can have when we have the break now for 10 minutes, I think. And before that, also when there are questions, feel free to raise them now.
Clara, are you there?
Yes.
Can we make a breakout room? Or how do we get questions?
I mean, students and professor can just unmute themselves and speak loud directly. We are not so many, we are 28. So I don't know if it makes sense to create breakout rooms, or if it's more easy to stay in the same.
Okay. Actually, I think it would be interesting to have breakout rooms for maybe like 5 minutes, and then we have another 5 minutes of just break, so you can just stretch your legs or something like this. Let me try to do this.
You can do that, or I have to do it from here?
I think, yeah, I can do this. Yeah.
Okay.
Okay, let's and maybe when we come back, each one person from each group can just maybe tell us what interesting ideas that you had. It would be nice for us to hear from your side as well. Okay, so
that's great.
I'm creating like around 4 people in a room. All right.
Lakshmi?
Yeah.
I'm going to stop for a moment the record, and then we are going to restart again. Yep.
Sure. Yeah. So I had some discussion in my group, but not so many. There was only Faith who gave me some response. I would encourage everyone to just tell your opinions and have ideas. I think there's no wrong answer, let's say, and we want to also hear from you and learn from you about how it is in Zimbabwe, and yeah, I think it's just super interesting for us. So we would love to hear from you. Okay, I think it's time for a break. So I would say we can take a break for around 5 minutes, isn't it, Christina? Right now? Okay, so we just Clara, I think you can just pause the recording, and then we join back in 5 minutes from now. Okay.
Yes, perfect.
We just stay online. You can just we just go on switch off our cameras and be on mute. Okay. See you in 5 minutes. Maybe at this point, I would ask once more if you guys have any questions until now. What did you think about what you heard until now? Was there any part that you read?
What I can say is maybe just to help the students from what you've been presenting so far. I would maybe want you maybe to kind of explain to them in terms of city planning, what the advantage is for 3D planning of the city as opposed to 2D planning of the city. I hope you understand what I mean by 2D planning, whereby in Zimbabwe, it's very common, whereby as architects, they just receive 2D layouts that are just planned to say this area is residential, this is commercial, this is what, without thinking in 3D, which is what they see every day as students. But I think we, as a country, we need to shift, and this needs to also be empowered on them, the students, to start to plan cities in 3D. So I would think that would also be very important for them to internalize that and to appreciate that. Thank you.
Okay, maybe I can give it a try. Nowadays, what you're starting to see everywhere is multidisciplinary planning. So you have different fields of expertise that they are very good at one topic, let's say traffic, let's say water management, let's say grid infrastructure, or let's say what we do, climate engineering. So working in 3D allows you to, first of all, to use these a model to evaluate, let's say, the effect of one building shading the other one, the effect of airflow in a construction. So you have different tools that there is another group of experts, let's say, let's call them the tool developers. Some people that are making new tools that help us to analyze different phenomena of a city. And of course, all these design environments are 3D right now. So I think that would be the answer. Let's say to have a broader analysis of all the aspects of city planning and sharing with other colleagues.
Yeah, I totally agree. When you say 3D planning, I think one aspect is literally, you're looking at the plan and only the top view. And when you say 3D, you have to also think about the heights of the building, what comes underground, the water infrastructure, the road, maybe subways, traffic, everything comes into play. So I think what we also do a lot of the times is we just take a section of the street. We just draw a section of the street so that we can also kind of detail how the street should look, what should be the widths, what comes underneath, like the blue infrastructure, like the flooding, how to avoid or manage flooding. And then you really end up thinking about all of these things when you have a section. You see, okay, where should the cars go? Where can the bikes go? Where can you walk? Where does the drainage go? Where does the electricity go? Is there a subway? What are the heights of the buildings? How is it shading each other? How's the sun? How's the wind? You know, all of these things come into play. And I think interdisciplinary working is really, really important. So I think it's really necessary to work with the engineers, not just like make a plan and then have other people continue on it, but really like consult each other at a very initial stage of the planning. Whether it's I don't think like nowadays you can start from scratch of planning a whole city, but this is also applied for smaller master plans, even if it's like a apartment block or yeah, like office, like these software companies, they build this whole what is it called, tech park or something like this. These are also like small cities that you can plan.
Yeah, and I maybe would add, even if like it's the same, the planning is usually 2D, and we really have to think more in 3D. And also maybe to add this dimension, the fourth dimension of time, because many things change over a day, over a year, over a week. We have days where a lot of traffic is, times where a lot of traffic, it's times where less. So this is also a dimension which is important to consider, but of course hard to depict. But the time is, as you heard probably in lectures before, when you think about energy curves, a really crucial point as well.
Okay, then I will share my screen again, and we continue with the lecture. No, this is the wrong one, sorry. Where was I? Okay, give me a second.
Then later on, I think we will talk about the issue of density after you've presented some things to benefit the whole class, because I think it's also another issue that I would need to highlight a few things to the students, and then maybe it can be a discussion later on, but you can proceed with the presentation.
Yeah, yes. We will hear more about it later.
Yeah, so we have some stuff about it for sure. Okay. I can do this presentation now. Okay. So the next section is going to be about mobility and outdoor comfort, and how does this fit in with how cities are shaped, or how they affect each other and our quality of life. Okay, so what we see here is, you saw this graph already, which shows what is the CO2 emission by economic sector. And what you see here is like 22% of it is by transport. So it's a big chunk that we have to look at. And if we see the details, 40% of that is by automobiles, and 34 is by trucks and delivery services. 11% is aviation, and the rest is marine and railways. Railways is quite a small chunk, even though it does a lot for us. Why is mobility concept so important when we think about urban planning? Because when we have a bad mobility concept, it affects so many aspects of our life. It can lead to heavy air pollution. This is an image of Delhi. This is how it's supposed to look on a clear day. And I'm sure you've read it on the news. In December and October, when it's winter, it really looks like this. I've been there. It looks like fog, but it's really smoke. It has one of the highest pollution, air pollution in the world. What else does it affect? It affects accessibility to not just humans, but also animals. What we do, or what we see everyone, all the cities are doing is, okay, we have traffic jams, so let's just widen the roads. We have 4 lane, from 2 lane it became 4 lane to 8 lane to 16 lane, and there's no end to it. And what does it do? There's nobody who can cross the street. If there's a dog, it can't cross the street. Wild animals, they're just like they're just left on one side or the other. And And it also gives more importance to car owners, which means only the rich or the people who can afford to have a car, only they make use of this infrastructure. And what about the other people who can't afford it, or who just need to go from here to there? It's like it's really hard, and it's not equitable. What else does a bad mobility concept lead to? It leads to loss of habitable spaces. Road widening means cut down trees, break down buildings. It has led to destruction of really old heritage buildings even. And then once it's gone, it's gone, right? You change the way the city looks, and it's not recognizable anymore. And it just looks like a bunch of roads. There's less space for people to live. If we are making roads all the time, then where are all these billions of people? Where will they live? Public spaces are then sacrificed as parking lots. This huge ground surface, they are all closed. They put concrete on it, and it's just there as acres of parking lots. It doesn't allow water to go in. It doesn't allow any plants to grow. It doesn't even allow people to use that space. It even is a safety issue, because parking lots, you don't feel safe in a parking lot either. What can a good mobility concept, what we can change a lot if we stop giving importance to cars and start giving importance to humans. This is a street in New York, and when such busy streets in a lot of cities, streets in the city center, they are being banned to cars, and then you see an instant change in the way people behave, in the way how people feel safe. It increases commerce. People want to hang out there. If they hang out there, then they buy more things. And if you're in a car, they can't get off. You can't stop there. You can't cross from one side to another. You don't feel safe to just walk around and just stay there, because it's noisy, it's polluted. Also, it doesn't feel safe, right? It doesn't feel welcoming. We saw the example of Atlanta. What does urban sprawl actually mean, and what does it entail? It just, all of this is suburbia. It's a lot of small houses and a lot of gardens, and these are fake gardens. It looks green, but it's a lot of lawns, and lawns are not like, it's not nature, because it needs a lot of water, needs a lot of water and a lot of maintenance. It doesn't allow any other natural species to grow in it. It doesn't really allow natural biodiversity to live in it either. What we want is like cohabitation. Humans are part of nature. We forget that, and we have to live with other parts of nature, which are like other animals, maybe fox, maybe birds, squirrels, so many animals, right? And okay, what happens when you have this large sprawl and suburbia? Everyone, you can't walk from, if your house is over there and your supermarket is over here, how are you supposed to get here? You need a car, you need a bike, you need something. And then you can't even go straight. You have to go all this way somewhere. It's not even well made, these streets. They always make you go around and around. And then you get onto the highway, and then you cannot possibly bike there or use a bicycle, because it just feels super unsafe to go on the motorway in your bicycle. And so no matter what you want to do, you need a car. You can't get to school, you can't get to a hospital, you can't get to your workplace without a car. And you have to drive kilometers long. And it restricts basically your freedom, right? If you don't have a car, you can't go. So your kids can't go. You have to drive everyone around, and you have to be rich enough for you. You have to afford to own a car and pay your insurance and pay your gas and everything. We are building cities not for humans, but for cars. So there is something that what suburbia results in. So when you plan cities, this affects basically your quality of life and your mobility concept. So it all goes hand in hand. That's when density comes into play. When you have denser neighborhoods, then you have shorter distances. And when you close up all this ground to make streets and parking lots, what happens? The water can't seep in. It can't go underground, and then you have floods. Christina already spoke about this a little bit on how to deal with it, is to just have more open areas, so like less closed surfaces, more permeability. And this means we cannot have so many roads and so many closed surfaces, right? And with climate change, we only have more of these events of heavy rains. Like it doesn't, like 2 degrees more doesn't mean, okay, it's slightly warmer. It means you have sudden rains and you have sudden lots of water that we haven't designed for it. And what you see here is, oops, I can't see, oops. Yeah, you see, Diego, do you want to take over?
Yes, sure. Yeah, I'm here. Here we see, well, each bar will represent 100%. And here you see in different regions of the world, how do people move? So here we see, okay, that of course, this use of car is not distributed equally. And there are some regions that are like where the red bar is very, very high. For instance, cities like Houston or LA, where it's, of course, car gives the people some comfort, but they are actually living in a city that is built for cars. So there's only one way around it, which is like this. And other ways of transportation, non-motorized, would be, let's say, walking and cycling. And here you see that we see a tendency to increase, like in and of course, for cars, there are different modes of owning a car, let's say, like sharing or having carpooling and so on.
Okay. Do you want to continue?
Sure, yeah. So here we see this transformation of the energy that we used. So more than half of it is for transport, and this can be broken down into what you see here. So cars are more than 75%, and out of that, here's what you see on the far right in purple. It's like vehicles owned by single users, and in most of the cases, you see that there is just one person driving the car and 3 or 5 empty seats. On the other hand, you see a bus. So let's say a bus can fit from 30 to 40 people. So just imagine what a traffic jam you could have with 40 cars, and you can have people only riding one bus. Okay, we can go to the next one. Okay, and this graph also shows the per capita emissions for transportation. So in the top, we see this region, North America, the United States and Canada, and then Australia, very, very similar lifestyle. And then Saudi Arabia, countries from the Gulf, and from South Korea. And then you see countries in Central Europe like Germany, France, Russia, Italy, and so on. And here, compared, we see the population density. We've talked about these regions. Let's say the most populated region right now is Asia, mainly China and India. And if you look at these two areas that are very densely populated, you see that they are on the final part of the chart. Also, if we focus on Africa, we're going to see that West Africa is the densest population.
So basically what we want to say is when you have denser cities, you just need to travel less distances, which means your per capita carbon emissions for transport will be much lower.
Mm-hmm.
And
okay.
Yeah.
And these are all choices that people make. So here we have the emissions for different ways of transportation. And here you see, okay, like moving in a ferry, very, very low. Moving in a motorcycle, also very low. And maybe the most impact is done by airplane. Now there is a fair comparison, like in some places where the infrastructure is available. Okay, should I fly or should I take the train? And here you see the answer. It's like less than 20% of what you have between a train and an airplane. Okay, so now we would like to know a bit about you. And speaking of ways of transportation, we would like to know when you go to university, we have 4 options. Do you walk? Do you cycle? Do you use public transportation, or do you use like a motorbike or a car? Who would like to participate?
You can
Maybe
just unmute and yeah.
Or write in the chat.
Exactly. You can just write a little on the chat, and then we're gonna see what's the most frequent way of transportation.
Okay.
Okay, we have the first one, public transportation. Okay.
Oh, there's a lot of public transport.
There's a pattern.
Mm-hmm.
Here we have a car.
We have one car.
Is anybody walking to the university? Does anybody live close enough to walk? Wow,
Yes.
we have.
Okay.
How about you, Diego and Lakshmi? How you go to the office?
I
take a bike. I cycle.
A bicycle. If I'm in Stuttgart, then I take public transport. If I'm in Berlin, then I just walk to my living room.
True. I take the
Okay.
e-bike.
Very, very
Right,
nice.
because Stuttgart is hilly, so but we do see like a lot of people in our office who used to have a car or used to take the train now. They are moving towards e-bike, the bicycle, basically electric, because Stuttgart is so hilly and it's just really difficult to take a normal bicycle. But a lot of people have been selling their cars and switching to an e-bike, which is really nice. Oh, there's a lot of people who are walking. That's nice. That's nice to hear.
Mhm.
Okay. So then we have another
okay.
question.
Yeah.
So can you walk to your nearest grocery store? It's just a yes or no. We just want to know how well connected your city is. Do you have services close by that you can just walk to?
Mhm. Okay. Well, my feeling right now is more yes than no.
Yeah, we have 1, 2, 3, 4, 5, 6, 7 yeses, 8, 2 no's. Okay. I
Okay,
think we have a,
let's move to the next one.
so is there a green public space or a playground in walkable distance to your house where you can just, I don't know, take a walk or exercise or just meet your friends or like your kids can play or something?
Mhm. Well, in this case, I can tell you that there is an indicator of the World Health Organization that tells you more or less that within 100 to 200 meters, it would be good if there is a green area for people living there to visit. So this is also, let's say, a metric that can be evaluated in different spaces to see what's missing there. And funny enough, they only have 3 metrics in this direction. They say, okay, more or less how many doctors or physicians does the population need, and also nurses. Okay.
Cool. Okay. So we then switch back to the lecture. Okay. So why did we talk about walking so much? Because walkability improves your quality of life, right? When you can get about wherever you want, you don't have to depend on anybody or anything. You can just walk, right? Building blocks and localities, they get populated. You meet people on the way. You have stores there. When there are more people, when it's more dense, more shops can open because it makes more financial sense for them. They are able to sell more goods. So then more stores are coming up. And we should design our cities in harmony with climate, so that we are able to use these spaces. They are usable, they're comfortable enough where we are able to go out and spend time there. And when you have such spaces, then it's more likely that people will go outside. So what are the factors that improves walkability? And this, when I say walkability, it also applies to, using your bicycle or just accessibility to things. When we have more dense spaces, that dense, like as in more floors, you can get to places easier because you don't have to cross kilometers of residential houses in suburbia to get to one store. When you have denser spaces, you also have mixed use developments, which means there's no like office block somewhere 2 kilometers from where you are, or like 5 kilometers where you are, and then there's only offices. But you have this, in the same building, you can have some floors which are residential. You have on the bottom, on the ground floor, you have shops and commerce, and maybe the middle floors you have offices. So this way, So people who work in those spaces, they can find accommodation that is close to where they work or where they need to go. So this just improves their quality of life, because they don't need to spend so much time or being on the road, having a car. You can just walk to wherever you need to go. It reduces distances as well. And this is what I was talking about earlier. It's about designing your street canyons as a section, right? So when you design your street well, so you have here, for example, here you have public transport in the middle. It could be trams, it could be buses. You have cars, and then you have also space for bikes, for bicycles, and you have space for people. And you also have space for people to stay there, and maybe cafes have space to put their tables or something like this.
And in many cases, Lakshmi, if you go back, it would be redesigning the streets, because in most of the cities, the streets are older than cars. So let's say if you imagine streets that are 100 years old, in the beginning were just used for walking, and then maybe, I don't know, with horses, and then the car just took all over this public space. So in many cases you see that even the population, and we have an example on that later, is trying to regain some spaces like the streets for different modes of transportation, like walking and cycling.
And people will want to walk, or they can walk if they feel safe only, right? So separating first of all, giving them a space to walk, having proper footpaths wide enough, straight enough that it's not always under construction, and it's separated from the traffic so that they feel safe to walk, and they're not also have a little bit better quality of air and things, and having lights so that they feel safe enough to walk, having it more open, and not having, huge walls next to it where you feel basically unsafe to walk. And coming then to the next topic of outdoor comfort, this obviously also improves not just walkability, but also how spaces are used socially. If it's comfortable, only then will you go outside and stay there. If not, you will be running inside. And how can we make spaces more comfortable? You can have plants, you can have furniture, you can have enough space where people can stay, right? But also you can design your cities and your and the road, basically the street canyon, and the building blocks in a more climate responsive way. You have heard of a lot of these concepts before, and this will maybe be a little bit of a recap, but also maybe some new topics are introduced here. So what is outdoor comfort? It is similar to indoor comfort, except, the influencing factors are similar. So you have influence from whether you're in direct sun, obviously you will feel hot or warm. If you're in a cold climate, then you will feel nice if you're in the sun. So it really depends on the context. Yeah. So solar radiation, direct solar radiation, but also diffuse solar radiation. And not just this, but you also feel heat from the surfaces that are around you. So I'm sure you've noticed on these dark asphalt roads, you feel it's really burning, like it's hot, you can't even step on it. Right, and also surfaces around you. So colors of the surfaces also matter. Wind, it makes you feel much nicer when it's hot, but it also makes it very cold if it's a cold climate. And air temperature and humidity, are very obvious influences of outdoor comfort. But apart from this, what you have personal control over is what kind of clothing you wear. This is the clo factor that you might have, if you remember from your first lecture. So dressing appropriately for your climate is the first thing that you can do. And I think in Germany, we have a saying where there's no bad weather, there's only bad clothing, right? And then activity is basically your metabolic rate. So if you're running or if you're exercising, then you obviously feel more warm, which means that your conditions, like where you are able to do this, is different. So in warmer climates, this is also a restriction that people don't tend to walk or bicycle so much because it's too hot, especially in the summer. This is all things that affect obviously your mobility concept, and we have to then rethink of how we can provide outdoor comfort to promote people to walk or stay outdoors. So the first thing you can look at is the most influential factor, which is the sun. So in summer or in hot climates, you want to block the sun as much as possible and provide shade. And in winter or cold climates, you want to have spaces where there is sun so that people can stay outside. And these are like different street canyons, what you can see how building affects outdoor spaces and the streets. So if you have if you have tall buildings and a narrow street canyon, then it's shading. So it's self-shading, so you don't have to have additional strategies or interventions to provide shade. So this is the best thing that you can do is design in such a way that you use all of these synergies to provide the conditions that you want. But what is happening is road widening is happening, and then what happens is not only unfriendly to pedestrians, but it also heats up the streets, and it absorbs all this heat, and then it gives it out at night. And this is also contributing to urban heat island effect. And what do we want for the future? How should the street canyons be, right? This is what you as architects can influence in the future. And this will be influenced by where you're designing. And if it's a hot weather, then obviously a narrow street canyon makes more sense to provide this shade. And then we can look at the ratio. So a general rule of 45 degrees will allow like a decent amount of shading, but also daylight to reach the buildings. So this is just showing you if you have like 20 meters high buildings, then what should be the width of the street or the width of the courtyard needs to be. And then comes the orientation of the buildings or the orientation of the streets, basically. So there are many options. I think traditionally it just happens organically, but when you're designing a master plan, then you can have a lot of influence on this. And instead of just doing it just aesthetically, I think it makes so much more sense to look at it functionally and provide enough comfort. So, for example, if you place it exactly north-south, like the streets, then this is July. So in summer, what happens is your east-west streets, these streets are basically never shaded because the sun goes like this, and you always have sun here. And the north-south streets, they will be nicely shaded, except maybe for a few hours at midday. But what happens if you have a diagonal street orientation? Then on average, the solar radiation that's falling on the street is lower. As you can see, it's around like 6-7, and here on a sunny street you basically have all so this is showing you the number of hours of sun, so you have more than 100 hours of sun. So what does this mean? You will have some amount of shade all during the day. Like if the sun is here, this side of the street is shaded, so people can just walk on that side of the street, right? And then in the evening, the sun comes from here, so this side of the street is shaded, and then people can walk on that side. So it's not necessary that the streets have to be shaded all the time. It's providing people options to move. And this is the sun hours for March now, where the sun angle is a little bit lower, but you see basically the same effect. This is for Canada, so the sun angle is much lower, but even then this works basically for winter and for summer, because in the winter you want a little bit sun, and then in this case, you know, some streets will never have sun, but in the diagonal case, you can choose where you want to walk, and if you want to be in the sun or if you want to be in the shade. And then building forms can also influence a lot of things, like the daylight access and also visual access, right? If you have these sharp corners, also it's a hindrance for people who are using the street. And then if you have these filleted corners, you have more, you have space for the sun to also reach this block. And then we design for the wind. In summer, you want wind flow, and in winter, you want to restrict wind. It's difficult to do this everywhere, but it's possible through like individual local interventions. So this is also something that you have already seen before. How wind moves when you have different street canyon shapes. So if you have a larger gap, yes, you do have more air movement. And if you have smaller ones, then the air just goes on top. And then different building forms, they can also be designed according to the wind. So in this case, you have cold night winds coming from the north, and you have daytime winds coming from the south. So we want to allow day winds, but we want to block the night winds. This is not the case in all the cities. So this is why you have to look at the climate in order to react to the climate. So in this case, you know, we are able to block the the night winds. But in this case, you're not able to block it. And you also just allow the daytime winds. And another example is when you have, cold winds, which are below 12 degrees coming from the west and the north, which you want to block. And you have nice cool winds coming from the southeast. So when you have such an arrangement, what happens is you're not blocking any of the cold winds, but you end up blocking the winds that you want. And in this case, it's designed to allow the winds that you want and block the winds that you don't want. So these are all the 3D aspects that you can think about when you're sitting down to draw your 2D plan, and then you're like, okay, what form should it be? Where should it face? Should it just be random, or can it be shaped by the climate? And then, okay, can you guess which city this is? Maybe we can just have some answers on the chat if you have. Can anybody just have just take a random guess? Anyone? What about now? Does this give you a little bit?
It should be any city in the Netherlands, either Amsterdam or...
Yeah, nice. Yes, that's the right one. That's great. Yes, exactly. You are right. It's Amsterdam. It's called the biking capital of the world. But it's also known for canals, right? How did this city end up being like this? It has these thin streets and it has a lot of canals. And this was shaped basically by the port and by the boats. So it was, the streets wasn't really designed by the city. It just happened organically because boats needed to go and they needed to deliver and unload and load. And that's how the streets end up happening. And because you had those small streets, and then in the 70s came the cars. So what do? You have a lot of cars, you have a lot of traffic jams. And earlier there used to be a large number of bicycles on the street, but around the 70s it drastically reduced in basically all the cities in Europe that you can see here, right? And this led to also destruction of neighborhoods, just to make space for cars, and you have these wide streets, so uninviting, and also loss of good architecture. But what you see now, you see this was in the 70s, so polluted, there's barely any people outside, and this is now where bikes are given more importance now. You see so many more people, you see people also sitting on the streets, you see so much activity, it's so lively, it's just the street is more alive. But how did this happen? It didn't happen actually. People think that, yeah, it was like great city policy, but it actually wasn't. It was because of the people, it was because of the public. So what happened was in 1971, there was so many deaths. There was like 3,300 deaths just in that 1 year, and 450 of them were children. And then people just were so angry, they didn't want to stand for this anymore. And so people went to the streets, they had protests, and they had this campaign called Stop the Kinmord, which means stop the child murder. And they had bicycle demonstrations, they occupied all these accident spots, they just stopped traffic, they put tables on the street, and even the police were helpful, and they closed like the streets on special days so that the children could play, like how Christina showed in Stadtlucken, where the parking lots were converted, but this was temporary to show what is the potential there. And then finally the city listened, and they started some small changes, like car-free Sunday, they put speed bumps, they put turnings, they put cars speed limits, but these were not enough. The most critical steps that were taken, which led to the success that we see today, was some of the things that I will say. So here you see it's about prioritizing rider safety. So just a line on the street is really not enough, because the cars, they will not take it seriously. Completely separated bike lanes with like physical barriers. They found to decrease fatalities by 44%, and also see an increase in the number of cyclists. And another key thing that people need to look at when designing these bike network is not to just have bike lanes starting from nowhere to nowhere. You just have one street with a nice bike lane, but then what happens after that, right? Then when the cyclists are then lost, they can't really get to where they need to go. So the bike network needs to be interconnected. Here you can see all the red lines, which are all the bike network, and it's so extensive. There's almost no street where you can go to anywhere in the city and not be afraid that to cycle anywhere, because you have space to cycle. They have over 700 kilometers. And you also need bike infrastructure, so like parking, making sure that it's convenient for people to bicycle. And then they also put restrictions for the cars. There was like a maximum speed limit of 32 kilometers per hour, which is slow enough that they are able to react to pedestrians and cyclists, which are given first priority. So the cars must yield to cyclists. This is what brought more and more people to switch to bicycles, because now driving a car was just a hassle, right? They have to go slow. They probably reach faster with the bicycle anyways. There are so many road bumps and everything. And another, the aspects, I mean, this is not like you cannot take these solutions directly and put it in your city, because every city, has its own special requirements. And what made it successful in Amsterdam was because the city was already dense. People didn't need to go so far. If you were to put these solutions in Atlanta, it would never work because they have such long distances, right? So first of all, a dense city means they don't even, like, if you need to bike for 10 minutes, it's not even, it's a no-brainer. You will take the bicycle. You don't want to take the car. Having mixed use is also what allows it to work. And in this case, the city is so flat that it requires less effort to bike, so everyone can bike. You saw the old person biking. You see everyone, like there's no like you don't see a uniformity in the kind of people who are biking. There's people who go to offices. They are very, very well dressed people. There's also people who are just going to the grocery store. Old people, everyone is biking, because there's no social restriction to it. And because also the climate is mild, it's comfortable enough to bike. So in cities that don't have this, for example, if it's too warm, then you need to provide shading or other measures to allow people to be outside and be able to bike. We have now another break, for which we have another discussion. So now the question is, what would you improve in your city if you had an unlimited budget? Right. Oops. So I will put you guys. Do we have enough time, Christina? Okay, so maybe
everyone can take in the break and think about it. And when you have something in mind, just write it in the chat. That would be really great. As Lakshmi said, that we can learn from you guys, and maybe just discuss when you meet someone in the break, or think about yourself, and write what you think about it just in the chat, or tell us later.
Yeah. So how many minutes?
We said 15 minutes. So at 3:25 back here.
Okay.
Yeah, very good.
Yeah. Before we go on the break, if anyone has any questions, feel free to just write on the chat. Yeah. Okay, we meet back in 15 minutes.
So welcome to the last part of the presentation, where we're going to try to answer this question: how can architecture influence the urban quality? And after that, I'm going to show you an example of a project we had in Nigeria some time ago. Okay, so if we focus in, let's say, the icons that you see in the horizontal line, you see that we try to have 4 steps in order to accomplish a sustainable, let's say, building or a neighborhood. So you see the optimization of the layout. We've covered this already, where you see that the distance between the buildings has a lot to do with how the sun is going to shine there, or if it's going to shine or not, or how is air movement going to be, and wind. The second part tells you, okay, how is the facade of a building working? Like, is it going to be very tight? Is it going to lose or gain a lot of energy? And the third point, this eta equals 1, represents the efficiency of a system. Let's say the efficiency of how do we produce electricity, how do we produce cooling, or how do you produce heating. And the final part, once you've got these 3 aspects right, you have reduced the energy consumption in such a way that you can cover it with renewable energies, for instance, solar energy. But in the case of a city, we can also look at it from a bird's eye view, or even from space. You know, you use nowadays satellites to see, okay, where is the location of a city, where is vegetation, which parts are permeable to water or not. And then out of this, you can pick a location, or if the location still exists, already exists, you can have a good idea of how the winds approach the city, or where is water, and then you can move to the second step where you optimize the city layout. And as a final step, you can think about the pedestrian level, where you see, okay, how are the materials that, let's say, let you know this is a path for crossing a street, or how is the vegetation also within the street canyon, and who has a right to, let's say, walk there, or cycle there, or drive there. So all these aspects have been studied by the United Nations. They have a research group called Habitat that analyzed many cities around the world, and they try to conclude, okay, what is working already in all these cities, let's say from Africa to Asia to Latin America and Europe. And they come to the conclusion that, okay, if you have from 5 to 6 levels, you're going to see a quality of the city where you can have a connection to the other buildings, and especially if you are up, let's say in the 6th level, you can still recognize who is walking at the street. And if most of the streets are between 22 to 30 meters, you're also going to have enough space for walking, vegetation, and transportation. Of course, you're also going to need some wide streets for important avenues, or to connect to other nodes like a railway station. And these ones could be from 60 to 80 meters. And they also mentioned that the minimum should be 18 meters. So you can also see that they concluded that if from the total area of a city, 30% is used for streets, and you have an open space of 20%, let's say for a park or water bodies, that leaves you 50% built. And this chart shows you once you have a certain area, there are many options of how can you build there. For instance, here we see 75 dwellings, and you put them in an area of a hectare. So one option would be what you have on the left here. You can just stack them up top to each other and have a tower. You can create buildings on the perimeter and having an open space, a park or a courtyard in the beginning, in the middle. And as a final idea, this is what we see, especially in urban sprawl, where you have simple rows of houses next to each other. Now, if we plot these 3 options into a 2-dimensional chart, let's say we call the floor space index, you see here FSI, you can also call it the floor to area ratio, like the amount of available soil that you have of the site, how many times can you multiply it into the height? Okay, so let's say if we have here 1 hectare, we can divide. We can say that the same area that you have here is stacked on the in this building, towering up. And the second dimension would be the ground space index, which tells you the percentage of area that you are covering. So for instance, this tower is having the same area that the site has. So you have here a 1, and it is using more or less 10% or 15% of the total area. The one in the middle has exactly the same area, the 75 dwellings, and it covers more or less 35% of the site. So the open part that you see here in the middle, 65% would be open space. And then you can have a other option where you're covering 60% of the site and having just 2 floors. So if you divide this number, the floor space index, by this number, this would give you the number of floors that you have. And these are these lines that you see here, the discontinuous lines. So roughly the first one would have a bit more than 13 floors, the second one between 6 to 5, and the last one 2 floors. Now you can do the opposite and divide this number, the ground space index, by the floor space index, and this would give you an index, the openness space ratio, and that is actually just the reciprocal number of the levels that you have. So now that we have this dwellings either stacked or next to each other, we can think about how big a house is. And here we see some information of the different size of houses in square meters. So here you see that very big houses you see in the United States, Australia, and Canada, and in very, very dense areas, let's say like Hong Kong, you have all the way to 45 square meters. There is an institute in Germany that came to the conclusion that at least a house to have everything you need, let's say a kitchen, a place to sleep, a place to eat, would have between 85 to 90 square meters. So you see that Germany is a little bit above that number. So to you guys, how many floors are in the house you live in? We have 4 options, A, B, C, D, from 1 to 2, 2 to 5, 5 to 6, or more than 6. So feel free to answer in the chat, and I will move on to the next slide. Now all these inputs can be a part of a parametric model, and this is also the question that you ask about 3D modeling. You can put this information here, and just looking at the coverage area or the floor to face ratio, you can put this information in the model and pick an archetype of a building. Let's say you can have a point house, you can have those are top views of a house, and out of that you can have all these outputs that are always going to be the information that you see in a building. So let's say if we have houses in a courtyard, then it would be more or less in the chart that I show you in the red spot. And of course, we can animate this, and you see that all the possibilities that you can think of can be plotted in this diagram. So out of that, you can add a second dimension that can be the area to volume ratio. Let's say how much of facade you need to cover a building, or the exposure to the sky here of the streets, and even though the proportions of the street canyon. So let's say if we have a street canyon of 2, this means that 2 times the elevation of the facade is the width of the street. So in this plot, you can see that it's in the in this corner, or it can be very wide. So this is an application of 3D modeling, and in some cases, some of the properties are fixed of this geometric models, but some of them depend also on the orientation and on the location that you are. So the importance of the location is that during the lifetime of a building, you have always the same site, and in almost all the cases the same structure. But let's say during this 60 to 80 years of a building, you have to remodel the facade at least once, you change the interior setting at least 3 times, and the systems, let's say for lighting, plumbing, and so on, more times. And of course, let's say stuff like furniture changes many, many times. So for city planning, if you get these first steps correct, is the best way to avoid problems in the future. So speaking of the building skin, I would say that would be the last part of the urban design, where they can tell you, okay, the skin in this location should be like this. And this is, I know that you have reviewed this with our colleagues, but the skin can have these 3 different properties, and of course you can have intersection between them. But for instance, once you know how much heat is going to be hitting a facade, you can say, okay, in this case, the outer cladding has to be light color, or has to be concrete to have thermal mass. And well, the second part is the city layout. Here we have one example of a street of an area of New York and of Paris, and these streets are between 400 to 600 years old, and the oldest building would be more or less 100 years old. So this lets you know that once you have a city layout, it's very likely to it's not very likely to change in the future. The buildings are going to be renewed, but the layout will probably remain. There have been some attempts to have one solution for an urban shape, and this is an interesting one. Like, let's say, like a formula that the Chinese government tried to do in the 1970s, where they say, okay, we put here some buildings, and the angle has always to be 27, and this regardless of the orientation or of the population that they have there. So it was a failure, and I think it was because they ignored this concept that the cities always have a gradient. So people have an agglomeration in the city center, and as you go outside, then you're going to have smaller buildings or more free space. And this is information taken from satellites that were taking pictures of the city of Munich. And here you have some information, let's say, on the population in the city center. Roughly 4.1% of the population lives there. And as you go outside, you see that this number increases, and then in the outer part, it decreases. Now, all this happens within a radius of 5 to 6 kilometers. We see other examples where you can have urban sprawl for more than 20 kilometers. So the question is, how big can cities be? No, and those are decisions that the populations have to take. And I have here one example of the city of Barcelona in the Middle Ages. Very, very narrow streets where there were a lot of problems with pollution and even health issues in the population. So at the beginning of the Second Industrial Revolution, they decided to expand the city and make a city where everybody can have access to light and air. And this is the first idea they came up. It was actually an engineer that did this plan with an orthogonal grid that would allow, let's say, place for cars, for walking, and also buildings will be ventilated and well illuminated. And here you see that this would be a great expansion of the city. Here you see the Mediterranean Sea, and this would be an expansion of more or less 5 times what they have at the time. And the first idea from 1995 was to have either blocks next to each other, or creating a lot of free space. But here, as you can see, the floor to area ratio increased from 1.5 to 4.6 is what they currently have, and this is due to the success of the city. So the city became very, very successful, and it attracted more and more people. So they had to react and make more buildings where they thought they wouldn't need one in the beginning, and also add some floors. And here you see an example of how an existing city with a system, let's say like a grid, can be densified. And what you see here on the right is like once you have this grid, some other some blocks can be used for other purposes, let's say like a church, like a small stadium, or like a prison. You can also have schools, a little bit of industry, and factories, of course. So here's a picture of Barcelona, and here you see like this many times densified city. And now a recap of what Christina showed, a comparison with a city like Atlanta, where there are many things that we can take out of this picture. The first would be the road of public transportation that they have, and the two constraints also that the city of Barcelona has, that on one side you cannot grow because you have the sea, and on the other side you also cannot grow that much because you have the mountains. But still, it is a very livable city, very walkable, and compared to other parts, cities like very efficient. Here you see these slide, we've shown it before, but you see the emissions in one case for roughly the same number of people, 6.9 tons of carbon emissions, and in the other case 1.16. So now that we have looked at the concept of the urban gradient, we can use this chart that I show you to plot not one solution. Remember the example of the Chinese government, but many, let's call it areas of solution, where you can know that a certain urban form has a good performance. And for instance, in this chart, I plotted what would be an efficient urbanization in Abu Dhabi, in Munich. I feel like less levels would lead to more solar gains, Mexico City, and so on. Now, if we think about the steps of urbanization, according to many urban planners, you can have these 3 steps being: 1, build the infrastructure; 2, make a division of parcellations of the different sites; and 3, erect the buildings. So what a developer would do is they would just invest, and they would do everything at the time. What we see in most informal settlements is that first people start to build, and once this urbanization is successful, it starts to grow, and then they say, okay, we need a little bit of organization, and then they divide what they already have. And as a 3rd step, they create the infrastructure. So water infrastructure, electricity infrastructure comes at the end. And we would like to make the case for a sustainable design where you can do 1 and 2, considering the 3 aspects. Let's say a climate responsive layout, like I explained before. And then once you have a city like this, you should also take into consideration, remember this lesson of Barcelona, if the city is successful, it's very likely that it's going to attract more people. And if that's the case, there are 2 options: to sprawl or to re-densify. And in this case, of course, the suggestion would be to make a climate responsive densification. Now, Christina, before the break, do I have time to show the example of Abuja?
Oh, the break doesn't count. Just ignore it and go on.
Okay.
Switched it.
Okay.
It was before.
Fine. So you still see my screen, correct?
Yes.
Okay. Now I would like to show you an example of where we tried to talk to a developer and talk him into not doing this, but trying to follow this approach. And this is a project I worked on in Nigeria some time ago. Do you see the presentation of Nigeria now, or do you see still?
We still see the other.
Okay, then I have to switch. Okay, so now this is the framework for the sustainability concept of Abuja. Going to make it bigger. So the it's supposed to be the expansion of the capital city of Nigeria, and a new district far from the very dense urban areas that they have right now, and next to the airport. So they wanted to have like a fresh start, because most of the ideas that they wanted to have here it didn't work out. And we were approached to have a vision for a self-sustaining, energy-efficient city in West Africa. So this strategy I presented before, we try to follow these 4 steps, where in the first place you optimize the city layout for solar gains and daylight potential. Then you minimize the energy demand, mostly with the building skin, like how big are the windows, what are they made out of, and also the opaque components. And then maximize the efficiency of production. Let's say in this case, cooling is very important, because they have a very hot and a hot and dry season. More on that is coming up. And then once you've done that, you can maximize the use of renewable energies. So let's start with step 1. We analyze different parts of the city here. Once again, using different tools and using 3D modeling. And we came to the conclusion that due to the closeness to the equator of this location, you can see that the impact of a tall building on shading on the neighbors is not that big. So let's say in this case, a block with 20 meters has a cast shadow or an area of influence from 18 meters. And if you go all the way to 100, this expands to roughly 20 meters. So this is a good case to be a little bit more dense without taking daylight from your neighbors. And of course, increasing the ground floor area. So this is the site. It's crossed by a river, and in the corners you see 2 mountains, and this is aligned more or less to the wind. So they have a wet season, hot and wet, I would say, from May to September, and a dry and hot season from October to April. So out of that, my colleague Lakshmishree showed you also already some examples of how can you react to the wind orientation with the streets. I'm going to go a little bit more fast on this one. So you would like to allow wind penetration, reduce velocity, and also this difference within heights creates an airflow. Let's say if the wind hits this building, a part of the airflow would go downwards and a part of it would go upwards. And mixing low rise and high rise allows you to have different uses within a building and also have the same area but with more daylight access. Then we did this study where we analyzed, okay, what happens if you have an overhang, and what you see here is on the x-axis the depth of the overhang, and the vertical axis you see the amount of energy that you use for cooling and lighting. And here you see, okay, this big bending here once you have 0.5. So this only a overhang of 0.5 meters makes a big difference. So of course, this is the suggestion for residential and for offices. We did a similar study for the window to wall ratio. And here we put also some numbers of what are the savings that you can that you can have if you do this ratios for 50% or 35%. And here we have the weather data of Abuja, you have very, very high temperatures, more than 40 degrees in the hot and dry season. Here you see the absolute humidity in gray, so it's very low. Then as the rain season starts, then the humidity increases, temperatures lower a little bit, but you also, the swing between day and night, which is, let's say, the amplitude of the red lines, also decreases, okay? So these are the steps we did as the first one to have comfort also in the interior, and then minimize the energy demand. This is, as I mentioned, mostly about the building skin, like what is the facade made out of, just the window and also the opaque parts. And we analyze what you see in Nigeria nowadays, and say, okay, maybe you can spend a little bit more of money on the facade, but this would give you savings for the future. And in this case, it's 18%. Also the systems for illumination and computers and so on. We also took a look into that, and the air conditioning units, where you can have what you see in many places, every room of a building with a single air conditioning unit, or you can have a central system that is used for the entire building. And of course, you can use surface cooling, either for the ceiling or from the floor. So we also took a look at the local regulations, and here you see, I guess you are familiar with this chart by now, where we'd like to go for the comfort in this area, and some limits of what are we going to allow or not, and if the systems that we're proposing are going to create the desired effect or not. So in the end, we make a simulation of the baseline. Here you see the demand for electricity for cooling during the whole year. So here you see every hour of the year, and then we made this run with the approach that the local planners would have, and then we compared to what we proposed, and here you see that it goes down. So if you downsize all these peak demands, you can also downsize the mechanical rooms and the mechanical systems that would deliver electricity and cooling. And here we see the reduction in cooling demand, which was 56%. Electricity demand went down to 38%, and the same for the peak loads for electricity and cooling. So here we are already by savings for 49%. Okay, now the energy production on site, we said, okay, you can have this system that I described. Just in every room you have a split unit, and this has an electrical efficiency of 2.5. Let's say for every unit of electricity that you put here, you get 2.5 units of cooling. Now this system can be more efficient if you do it centralized and you put these units on the roof. Then the efficiency increases to 3.5. And then you can have a district system where you do a very efficient cooling somewhere in this place, and then you just using pipes, using the infrastructure, you pump the cold water to the buildings. And now this increases the efficiency to 8.5. And here you see an example of the kilo units that we proposed. And of course, here you see in a typical warm and dry week, this swing that I described between day and night, that is also going to make the cooling more efficient, at least this part of the season. So here we have a plan where we localized where would you need this system to be, and then we just made a sketch of how would this infrastructure look like. And this infrastructure should also be able to produce electricity. In the first place, this is a combined heat and power production, so it's actually burning fuel, and where that fuel should come from comes in the next slides. But here you see that from, let's say, a diesel generator that what's the first idea? You can reduce the emissions to 45%. And now that you have done these previous 3 steps, you can maximize renewable energy production. And we took a look at the solar output of photovoltaic panels in Abuja, and you see that the power output, if located horizontally, it's quite continuous. So you have almost all the same. And here between June and August, you have a little bit less because of the cloudiness of the rain season. And we also compared, let's say, with another location like London to say, okay, if people invest in PV, even in London, in this case in Abuja, you could get almost double the electric output. So for that, of course, there are some rules that you have to follow to make this system efficient. And then we also took a look at the waste that the city is going to produce. And we thought, okay, out of that, you can make an incineration plant where you can also turn this into energy. Now, in all these cases, it is never the case that with all the waste of a city, you can produce 100% of the energy. If you accomplish 5 to 7%, it's a very good number. This is more or less what we had here. But also you can also have other systems like biogas to produce fuel, and that also can be used for electricity production. So now, following these steps in this journey that I try to describe, you see a reduction in one case of power demand and also in the CO2 emissions. And here you see that it drops at every step, and in the end, you have a reduction of 96%. This chart shows you that in the beginning, you have this blue chart that goes to the bottom, that you have to invest a lot of money in the beginning. We call it the premium for the sustainable city, which is roughly a premium of 8.5% of the total investment of the city. And now all these bars shows you the running costs that you have every year, so they will increase slightly, but these bars are, let's say, 96% less of what you would have. So this gives you a return in your investment after 5 years, which is very, very quick. I think this is the last slide for this example. So if you have questions, I think it's a good time now. I am going to jump back to the main presentation. You should see right now.
Yes, we do. Let's see if some of the students has any questions. Guys, you can simply unmute yourself and speak loud. Or if you prefer, you can write in the chat.
Okay. Doesn't seem like questions.
No.
Yeah.
Okay.
Diego, should I continue?
Yes, please, Lakshmi.
Can you go to the, wait, maybe I can share my screen then.
Mm-hmm.
Okay, you can see my screen, right?
Yes.
Okay. So after all that we've heard, what does the future look like? What we want is carbon neutral cities with a good quality of living. This is something that we need to balance. And what is nice to know is that many cities are planning
to work towards this, right? So for example, there's oh God, how do I get rid of this? Yeah. So there was a carbon neutral city alliance that was formed in 2014, where 17 cities had organized the meeting and became part of this and had different targets that they set for themselves to meet with the climate change policies or the climate change targets, to cut basically greenhouse gas emissions by 80% or more by 2050 or sooner. So different cities have different, they all have different emissions already and different sources of energy and different mobility concepts and different densities. So it's all very individual solutions that they need. And therefore they also have different targets. So just as an example that Amsterdam has a target of reducing 95% of their emissions by 2050. And they want to reduce, they want to have zero carbon emissions of their transport by 2030 already. And they're already at a good way because they are the biking capital of the world, right? And if you look at Helsinki, they want to reduce 80% of their emissions by 2030. That's really close, actually. And they have already reduced their emissions by 33% since 1990. Yet have 65% increase in economic growth. So the argument that that a lot of people say that sustainability means no economic growth is totally false. And this is something that we should keep in mind and also educate other people about this. And their energy mix still has 43% coal and 34% gas, which is non-renewable resources. And they have a target of having 20% renewable energy by 2020, which was already last year. And they achieved 24%. So they're also doing a good, they're in a good way. And if you look at Oslo, they have already achieved their target of having 100% renewable electricity supply for the whole city because they have hydro. And they have little like 1% gas and oil, but this was 2020. And they want to reduce their emissions by 95% by 2030. And if you look at Adelaide, they have the most ambitious target of having 100% emission reduction by 2025. Yeah, and I mean, looking at all this, I think it just makes you, at least it makes me hopeful that other cities will take suit and take this more seriously to make carbon neutral cities and to really work on the electricity grid and all the heating and cooling strategies to really control what is happening. And Diego, do you want to conclude?
Sure. To conclude, there are some hints from the United Nations Habitat where they say, okay, actually, we need a three-legged approach. So you have good rules and regulations, which is like who is able to build what where. Those have to be clear. We try to focus a lot on urban design, and that was the main topic of this presentation. But in the end, there are other aspects, let's say like the financial plan, like where are the resources going to come from? And what you see here is an example of, let's say, a project of redensification, where not redensification, but readjustment of plots, where they convince people to give some space away to create space for roads. So just at the moment that you do that, you increase the value of your site. And of course, you can make it, you're also leaving space for illumination, and you're also leaving space for airflow. So this is one idea of how even in existing contexts, this can take place. And another, I think, very interesting example of financial plan is the way Hong Kong works. They realize that, imagine in the example that I have here, if between plot B and G, someone made a bus station, then this bus station is going to attract people. And when they attract people, they're going to be like small businesses next to it. Like, let's say someone sells groceries, or someone sells food, or someone sells, let's say, even clothing. That's all what you can have. So actually, with public transportation, you're also creating a node that attracts people. And this example of Hong Kong, I think, is very interesting because they realized that, and they decided to buy some land before they built some stations there for subway or buses. And once they build them, of course, the value of the land increased a lot. So all the money that they get from rents and so on, it's invested directly into the public infrastructure and transportation. So I think these these three aspects are very interesting, and I think maybe in the future for you as professionals, you can be either doing urban design, or maybe drafting a financial plan for the revenue of a city and what do we do with it, and finally with the rules and regulations. So I think that's about it from our side. We'll be very happy to get some feedback from you, and also some questions are always welcome. Well, thank you very much, and thank you, Lakshmi, thank you, Christine and Clara, for your patience.
And thank you, Diego.
Thank you very much, Diego, Christine, and Lakshmi. That was really great. I will motivate again the students to maybe unmute yourself and make some questions. We have still a bit of time, so take the chance, and whatever doubt you have, whatever curiosity, whatever things you want to dig more into it, just feel free to ask. Students as well as professors, since I still see Priscilla and Teresa connected. Let's see, you can even write in the chat, as I mentioned before. Nope. Okay, it seems that we have no question. That means that you guys were perfectly explaining everything, and there were no doubt remaining. Okay, so once again, thanks everyone for attending. Thanks Diego, Christine, and Lakshmi for giving the lecture. I see one microphone that it's now unmuted. Let's see if somebody wants to say something. Okay.
Hi, Clara.
Aha, hello. Hi, Priscilla.
In your time, sharing with us so much knowledge. Thank you so much. Thank you to your fellow colleagues.
That's great. Thanks to you, Priscilla.
It was really informative.
Yes, thank you so much, Priscilla, for managing all the organization from your side, from the university side. Yes, I think we have shared a lot of knowledge from our side. I think you and the students might need a bit of time to digest all of this. And if even in the next days or weeks, there is any question, you can always write us.
Was Clara. Bye.
I cannot hear you very well, Priscilla, right now.
And thank you, my class.
Oh, I think she got disconnected. I don't see her anymore in the list. The participants, okay. Maybe meanwhile, there's somebody else that want to share a feedback, a comment. What do you think about these topics?
I just want to add a question. It was supposed maybe to be sent to the panel, but then it found its way to me. Okay, the question is talking about this one from one of the students. It says mostly of the Paris Agreement talk, it's centralized on carbon emissions, yet there are also some poisonous gases which are even emitted. Why is it carbon is emphasized more than the other toxic emissions? That's the question.
Okay, guys, there's somebody that wants to answer first.
Yeah. Well, I think you raised a very interesting point. I mean, of course, there are other gases. Let's say methane is like 10 times like more pollutant than CO2, and we know that. But well, probably because CO2 is the most common gas, and also because it has been proven where it comes from. You know, there were in the beginning some people saying, yeah, climate is changing, but it's not carbon. And in the case of carbon, you can analyze what's in the atmosphere right now, and carbon ages. So you can know more or less exactly how old it is. And we know that it's like carbon that has been in the ground for millennia, and it's carbon that was stored below the earth, turning into gas or oil and so on, and it has been released now. So I think maybe the focus is because of that, but as you said, it doesn't mean that other emissions are not important.
If I may add to that, I think it's a really good point. That is why, I mean, in our presentation, we also have all these other topics to have a more holistic design of cities, and it's not only about carbon dioxide, but it's also about, you know, health and well-being and livability and all of these things. But when it comes to, you know, the Paris Agreement, it's focusing on basically one topic, which is global warming, and we know that CO2 is the main cause. There are also other gases that make global warming worse, which is also why the metric that they've chosen is you know, carbon equivalent. And it's not just carbon dioxide in tons. So they also count other gases, and they convert it into what would it be in terms of carbon dioxide. And I think when you want to solve a problem such as climate change, and I think need to sort of focus everyone's attention to one thing and make it sort of simple for everyone to understand. So because I mean, if we look at everything, if we look at all the different things that obviously makes our cities better, then you sort of lose focus on one topic. So I think, in my opinion, this is why carbon is given more importance, and also it gives you a metric, and it gives you like solid numbers and targets where you can assess the progress of different cities and different places and the world, basically. And yeah, that's what I think.
Great. Thank you very much, guys. Is there any other questions? Okay. Okay, good. Nobody wrote in the chat. Okay, perfect. Then I think we can slowly come to the end. Once again, thanks a lot to all the participants, to all the students, the professor, and especially to you guys, to the speakers, Diego, Christina, and Lakshmi. I think we really shared a lot of important knowledge that I hope that all the students can take as a base for digging more into your private studies. And I think I hope we really were able to raise your interest in this topic. As mentioned before, if you have any questions from now on in the next weeks, months, we are always here. So feel free to reach out to us and we will be extremely happy to have a discussion with you. Okay, maybe as a last goodbye, you can turn on again your camera and your microphone and we can say goodbye all together. And let's see, I see Innocent.
I think for us, it was a lot of fun also to prepare and also for us to like talk about all these topics and prepare this whole thing together. So we also enjoyed it a lot.
That's great. Thanks a lot, Lakshmi. I see somebody. Thank you so much as well. Okay, somebody's writing in chat. Thank you. Okay, then I wish you all a great evening.
Thank you, Clara.
Oh, we see some cameras. Great.
Diego. Thank you, Christina. Thank you, Lakshmi.
Thank you.
Yeah, thank you very much.
Thank you as well. Thank you for listening.
And for organizing, Clara.
Yeah, that's my pleasure. I will also thank again the professor, especially Priscilla and Innocent, that took care of all the organization from the university side. So thank you, actually.
Very cool.
No one to thank. We are not yet that, Clara. Still to thank you even more.
That's my pleasure. Okay, yeah. Then have a nice evening. Hope to receive soon all your feedbacks. Thanks again. Goodbye to everyone.
Thank you. Bye. Thank you.
Bye.
Bye, everybody.